Okay, question 4.9. We are asked to determine the magnitude and direction of the resultants by drawing a polygon of forces. The easiest way to approach this is we can replace the two horizontal forces with one force and likewise with the two vertical forces. So minus 5 kilonewtons, and it's minus because it's acting to my left, plus 10 kilonewtons acting to my right is equal to 5 kilonewtons acting to my right, because the assumption that I'm making here is some of the forces in the x direction to the right are positive and forces in the y direction, going upwards, is also positive. Alright, so I can replace those two forces with a 5 kilonewton force acting to the right. If I do the same thing with force in the y direction, I can say that 4 kilonewtons minus 6 kilonewtons, and it's minus 6 because it's acting downwards. Okay, so that force can be replaced with a minus 2 kilonewton force. In other words, it's a 2 kilonewton force acting down that way. If I draw a triangle of forces, I know I have 5 kilonewtons acting that way. I know I have 2 kilonewtons acting down. So my resultant force is there. So I'll work out the resultant force and also the angle of action. Okay, so the resultant force using Pythagoras' theorem, r squared equals 5 squared plus 2 squared. So r equals 5.385 kilonewtons. What is the angle? The angle simply is tan theta equals 2 divided by 5. So the angle is 21.8 degrees. So the resultant force is 5.39 kilonewtons at an angle of 21.8 degrees below the horizontal. Okay, question part B. Now, if we aren't going to solve this one purely graphically, I am just going to draw up a table of forces. So I'm going to say that forces in the x direction, in that direction, positive, and forces in the y direction going up are also positive. So my table of forces will incorporate 3 forces, make this one force 1, force 2, and force 3. 1, 2, and 3, and my sum of the forces down the bottom Okay, let's have a look at force 1. Its horizontal component is acting in that direction and its vertical component is acting upwards. So the horizontal component is minus 150 newtons cos 30 degrees. Vertical component, because it's up, it's positive, so it's 150 sine 30. Force 2. Now, its horizontal component is to my right, so it's positive, and the vertical component is upwards, so it's also positive. So vertical component 150 cos 30, and the horizontal component is 150 sine 45. And I made a mistake there, that should have been cos 45, not cos 30. Okay, force 3 is working horizontally, so there will be no y component. So it's acting to my right, so it's got to be 300 newtons to the right. If I add all those forces up, or add up all the x components, so minus 150 cos 30 plus 150 cos 45 plus 300 newtons is 276.16 newtons. Because it's positive, it's acting to the right. Okay, if I add all the y forces up, I will end up with 181.06. Because it is positive, it is acting upwards. I can then draw up a triangle of forces. Horizontal component is 276.16. Vertical component is 181.06. The resultant is acting in that direction, and I also need to calculate the angle that it's operating at. Using Pythagoras theorem, r squared equals 276.16 squared plus 181.06 squared. So the resultant equals 330.2 newtons. What is the angle? Well, the angle is tan theta equals 181.06 divided by 276.16. So theta equals 33.25 degrees. So the resultant is has got a magnitude of 330.2 newtons at an angle of 33.25 degrees.